clearly see the beam over there. So the beam comes out, and then if you look in Abby, the spot will be right over here. This is where you can see the tail right there. And
it's a 7 kilo electron.
Yeah, that's it. You can see the filter sequence here, the 4278 filter right there. There's another beam fire.
Brian and I being the operators call these our photon torpedoes.
So I think this is the last one here. It shows the beam propagating, across the screen as we did our activities. So I'll go ahead and stop it and move on to some other payload activities.
The key here was to know where that photon torpedo, as Charlie described it, was going to go. And so I spent a lot of activity running a program where we would see which window to look through to find out where that thing went.
But Mike, shouldn't it be an electron torpedo?
Yes, it was actually. But we were only seeing it thanks to it. One thing I'll mention here, the way it looked is in those images straight out of the aft window, yes, it looked like a narrow pencil beam, just a thin, straight beam with no divergence. But even as you look to the window from which it was then going on towards the surface of the Earth, generating the aurora, not the surface, to the atmosphere of the Earth, you could see a visible spreading of the beam. And Byron mentioned this, there was already a curve, the first turn of the helix as it found its way along the geomagnetic field down towards the aurora australis.
You want my glasses?
Well, we get to the part here that excites Ryan and Charlie and I. We spent a lot of our time on the flight deck training to do this particular part of the mission, and then the other part where we come back and land. And so we do a lot of training and get really ready for this. And then when we launch, everything works, and we get on orbit, and it's time to turn it all over to all these really smart scientists. And what we say is that 90% of our training is now down the tubes, because everything worked fine. We trained for contingency after contingency after contingency, and that's the way that goes. But it's an exciting part of. But then we get on orbit, and since we launched just a little bit late, was it 20 minutes, 30 minutes late, just because of some weather considerations and stuff, and we have very carefully, the planners on the ground have trained and planned, and we've trained for an exact time of launch. And when that launch changes by even 20 minutes, all our maneuvers and everything is carefully planned for the time of launch. So when that changes, the whole flight plan has to change. This is early on our very first on orbit. Brian is receiving the 8 feet of teleprompter messages, which are all the changes to the flight plan for the first day. And so we have to go through all that. And so there's a lot of operational support that goes on to support the scientists to make sure that we can point the orbiter in the correct directions and do all those kind of things that we need to do. In addition to that, we have what we call in-cabin payloads. And as you can see, I was on the red shift, so there's my red shirt. And doing an in-cabin experiment. And in addition to these in-cabin experiments, a lot of times we're either changing filters, cleaning things, doing water dumps, making sure that the orbiter is pointed in all the correct directions. So there's a lot of teamwork activities that have to go on between the science crew and the orbiter crew that is doing all these together. So it's a very carefully choreographed mission that goes from start to finish, and it ran, as Charlie was saying, 24/7. We were operating this thing and continuing on. And it takes a lot of effort from everybody to make sure that we're pointed in the correct directions and we're doing what we need to do to make that happen. And then one of the things that we do is the mission, and we get to see these 16 of these every day. Those are sunrises or sunsets. And this is what the whole mission was about looking at the sun, the atmosphere.